Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the fifth question from the final examination, which was written in the year of 2024. Yes guys, we are still doing mathematics paper 1, and please guys do expect a total number of 12 videos, since the question paper is 12 questions in total, and that simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your final examination. So please do share the video to your peers so that they may have the same edge as you. And please guys, do help us grow the channel by just subscribing. Okay, we are told that sketched below is the graph of f of x having a domain which is that one, and we are also told that the graph of f cuts the y-axis at the point 0 and 1, and the line of symmetry of f is given by that equation over there. Okay, since we are given the domain guys, since we are given the domain, that means we can find the value of p. Are you together? Since the vertical asymptotes on the graph are on the line where x is equal to a positive 1, I can therefore conclude that p is equal to a negative 1. So f of x guys is basically equal to a all over x minus 1. We don't know the value of q. Are you together? But we can find the value of q by simply using the axis of symmetry. Are you together guys? But before we answer these questions, let's see the order in questioning of the examiner. Okay, the first thing they want us to do is to write down the value of p. Note that guys, they didn't say calculate, they said to you write down. That means it's something that you are supposed to see. Are you together? Since our vertical asymptote is that x is equal to a positive 1, therefore p is equal to a negative 1. Okay, and then now they want us to determine the equation of the horizontal asymptotes of f. Basically, they want us to find the value of q. Are you together? But remember that guys, we have our axis of symmetry. Our axis of symmetry intersect where both our asymptotes intersect as well. So the value of x over there is 1, and the value of y, that's q. So since the equation of the axis of symmetry is x minus 3, for me to find the value of q guys, I just need to substitute this point on that equation. The y value is q and the corresponding x value is 1. So therefore the value of q is just negative 2. The equation of my horizontal asymptote y is equal to negative 2. Okay, so now guys, I have the value of p as well as the value of q. So I can rewrite my equation like this now. I can rewrite my equation like this. I'll simply say f of x is equal to a into x minus 1 and then minus 2 over there. Okay, and then now guys, we are being asked to find the value of a. How can I find the value of a? By simply substituting a point which is on the graph of f of x. Remember that guys, we were given the coordinates of our y-intercept over there. We are told that y is equal to 1 if and only if the corresponding x value is 0. Let me write this with a different color just to show that I'm substituting. So y is 1 and x is 0. We still have a negative 1 and minus 2 over there. If I take this negative 2 to the other side, it will become positive, and then on the left hand side I'll simply have 2 plus 1, which is equal to 3, and then at the denominator I'll simply have negative 1. So a divided by negative 1 is basically negative a. I can divide both sides by negative 1, and therefore my answer will be my answer will be negative 3. So A is equal to negative 3. A is equal to negative 3, right guys? So this simply means the equation, the complete equation of f of x is negative 3x minus 1 minus 2. That's my equation, yeah? Okay, now let's answer the following questions. We are being asked the values of x for which our graph is greater or equal to 0. This thing, guys, of f of x being greater or equal to 0, basically they want us to find the values of x for which our graph is above the x-axis. Are you together? Our graph is above the x-axis, guys, only in this region, between the x-intercept and our vertical asymptote. So if we can find our x-intercept, we can therefore be able to answer this question over there. Yeah? How can we find the x-intercept, guys? By simply making y 0 and solving x. Excuse me. So if y is 0, let's go and find x. If I take this negative 2 to the other side, it will be positive, and then I'll have negative 3 over x minus 1, yeah? And then I can multiply both sides, or rather I can just cross multiply. I will end up having 2x minus 2 is equal to negative 3. Then 2x is equal to a negative 1. Therefore, x is just equal to a negative half. So my x-intercept over there is half. So my graph, guys, is above the x-axis when x is between negative half and 1. But remember that, guys, there was an equal sign over there, né? But I will only include the x-intercept over there because my graph is real on the x-intercept. However, my graph does not touch the vertical asymptote. That's why I'm not including 1. So this is how I'm going to express my answer. But for those who like expressing their solutions in interval notation, they can simply write y is an element of negative half and 1 like this. So the solution over there, x is between negative 1 over 2 and 1, and then x is an element of negative half and 1. I don't know why I wrote y over there. It's x, ne? Excuse me about that blunder. Okay, guys, you can express your solution as an inequality, or you can express it using the interval notation. Okay, and then now, guys, we are told that f of x undergoes a transformation to h of x, where the domain and range of f of x are the same. Okay, and then we are told that h prime of x, the derivative of h is negative. So they are basically asking us to describe the transformation that occurred. For us, guys, to have a graph of h of x which has a negative derivative, guys, simply means our graph will be decreasing. All right, together. If you can check here, if you can check the original graph for f of x, guys, have a positive gradient. Why? Because for all values of x, the graph is increasing, except for x being equal to a positive 1. Are you together? If you can just check, moving from left to right, your graph is going up. Moving from left to right, your graph is still going up. Né? So I can therefore conclude that if a is negative, my graph will be increasing. Are you together? If a is negative, my graph will be increasing. But if a is positive, my graph will be decreasing. So basically, for them to obtain the graph of h of x, they've changed the sign of a, number 1. Number one, they've changed the sign of A. So after changing the sign of A, guys, there's only one way in which you can change the sign of A. If f of x is equal to negative 3 over x minus 1 minus 2, you can only change the sign of A, guys, if and only if you are going to reflect your graph on the on the y-axis. Are you together? You can reflect your graph on the y-axis, or you can reflect it on the x-axis, right? So if you but remember that, guys, with everything you're going to do, the domain and the range should just remain the same. The domain and the range should remain the same. Okay. I can simply reflect my graph. I can reflect the graph on the line y is equal to negative 2. This is the first thing that I can do, guys, for me to have a graph with a positive gradient, né? Because if I do so, I will simply have a graph which looks like this. A graph that looks like that. Are you together? If you can check here, guys, our graph is a decreasing function. Remember that we must respect this statement again. Our graph is a decreasing function, né? But also another thing that we can do is to simply we can reflect the graph on the x-axis and then translate it downwards again. Are you together? If we reflect the graph on the x-axis, we are changing the sign of y. So for us to get h of x, we are going to say negative f of x, right? So that's negative. Remember, we have negative 3x minus 1. Still have a negative 2 over there. And then there's just positive 3 into x minus 1. And then there's positive 2. But remember that, guys, we're told that both the range and domain should remain the same. So if you want to go with the one of reflecting on the x-axis, yes, reflecting on the x-axis is correct. And then secondly, guys, you must just translate your graph 4 units down. For this y value to be equal to negative 2, it must be translated 4 units down. It must move from 2, 1, 0, negative 1, and negative 2. That's basically 4 units down. Now it's together. So you can say that the graph of h was obtained by reflecting the graph of x on the but the graph of h was obtained by reflecting the graph of f on the x-axis and then translating it 4 units down. Are we together? Or you can simply say by simply reflecting your graph on the line y is equal to negative 2. That's how, guys, you're supposed to tackle this question. I hope, guys, the video helped you out. Just stay tuned and wait for more videos.